Hey everyone, welcome back. Today we're going to look at sigma notation. If you've completed the previous two videos here, today's lesson will be a lot easier for you. So arithmetic series is in the grade 10 playlist and geometric series is in the Pre-Calc 11 playlist. So here we have sigma notation here. This letter here is sigma. And we're going to go from k equals 1 to 5. And then so all of this together is called sigma notation versus expanded notation like that. And so this k value is called the index. And so what we do here is you plug in 1 because it says k equals 1. And then you go plus. And then you plug in k equals 2. So that's a2 like that. And then you go plus. Plug in k equals 3 plus. Plug in k equals 4 plus, and then you go all the way until this number here on the top, which is 5. And so plug in 5 and then no more pluses because it goes from k to 1 to 5 like that. So let's practice expanding here. So example 1, sum from k equals 1 to 4. So we plug in k equals 1. So in this case it's 1. Then we go plus. Plug in k equals 2, which is 2 like that. Plus. Plug in k equals 3 plus plug in k equals 4. And we stop because it goes only from k to 1 to 4 like that. B, here it starts at k equals 3. So we plug in 3 there, so 3 squared plus. Plug in 4, 4 squared plus. Plug in 5, 5 squared like that. And so from k equals 3 to 5 like that. And this equals a number. This sum does give something, but right now we're not practicing that. Right now we're just going from sigma notation into expanded notation. So C, k equals 1. We plug that in here, so 2 times 1 minus 3 like that. Then we go plus, plug in 2, 2 times 2 minus 3 like that. Then we go plus, and we plug in 3 like that. 2 times 3 minus 3 like that. D, we plug in 1, so 4 times 1, plus, plug in 2, 4 times 2 plus, and then we go dot, 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 because we're going to go all the way to 30, so 4 times 30, and then we stop there like that. E, k equals 1 all the way to 6, so here we have 1a1 like that, plus, k equals 2, 2a2 like that, 3a3 plus 4a4 plus 5a5 plus, and then 6a6 as it goes until 6 like that. F, k is from 1 to 4, so we plug in k equals 1 like that, plus, plug in k equals 2, plus, plug in k equals 3 plus, and 4 like that, because that's the last one. Okay, time for some practice. A, B, C, D, E, F, go ahead and pause the video and expand those sigma notations. Okay, we're back. Plug in 1, so 1 plus 3, plus, plug in 2, 2 plus 3 plus, plug in 3, 3 plus 3 plus, plug in 4, 4 plus 3, and we stop there at 4. B, start at 3, so 3 times 3 plus 3 times 4 plus 3 times 5 plus 3 times 6 plus like that. K equals 1, so a1 plus 4 plus a2 plus 4 plus a3 plus 4 like that from 1 to 3. D, from 1 to 40, so 1 over 6 to the 1 plus to the 2 plus dot, dot, dot to the 40 like that. E, plug in 1, so 1 cubed plus 2 cubed plus 3 cubed plus and 4 cubed like that. F, k equals 1, so 2 times 1 over 1 plus 3, plug in 2, 2 times 2 over 2 plus 3, plug in 3, 2 times 3 over 3 plus 3 like that. Okay. Example number 2. Now we're going the other way. Write each sum in sigma notation. So here we notice what's changing is 3, 4, and 5 like that. So we're going to start at 3 plus plug in 4 plus plug in 5 like that. So k is from 3 to 5 of just k. B, we notice that there's a minus 2 for all of them. So something minus 2. We notice that it's 1, 2, 3. So it's k going from 1 to 3 like that. And that's it. C, we notice that there's always a 2 and a square. So 2 and square stays like that. We start at 2, so we go 2, 3, 4. So from 2 to 4 like that, with k being squared. D, 5 times 1 plus 5 times 2 plus all the way 5 times 26. So we notice that it's 5 times something for all of them. What's changing is this number beside the 5 that's being multiplied. So that's our k value, and we're going from 1 to 26 like that. E, what's changing is the subscript here, 1, 2, 3, all the way to n. So we're going from 1 to n. A, k, the subscript k like that. And that's it. Okay, practice number 2. Write each sum in sigma notation. So A, B, C, D, E. Go ahead and pause the video and answer that. Okay, A, we notice that 7, 8, 9, 10. So we're starting at 7, ending at 10 like that, and it's just K. B, 8 times 1 plus 8 times 2 plus 8 times 3. We notice the 8 is always multiplying something, and the K value here is going from 1 to 3, so 8K like that. C, B1 all the way to B4, so we notice the subscript, what's changing is K like that, and we're going from 1 to 4 as such. D, the only thing that's changing here is the exponent, so the exponent k like that, and we're going from 1 to 22 like that. Next one, we have 3, 3, 3, and square, 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 so 3k squared like that. 3, 4, 5, so k going from 3 to 5 as such. Okay, a couple reminders here. For arithmetic sequences, this is our formula, this is for our series. Geometric, this is for the sequence, and this is for our series like that. We've seen this before. So now we're going to look at some sums. So here's an example here, k from 1 to 4 of 2k. So it's 2 times 1 plus 2 times 2, 2 times 3, 2 times 4 like that. This gives 2, 4, 6, 8. We notice that it's an arithmetic series. We're going plus 2, plus 2, plus 2 like that. And so in general, if f of x is a linear function, then the sum from 1 to n of that function being evaluated in k is an arithmetic series. So this is like a 2k plus 0, right? That's a linear function, and we get an arithmetic series like that. So if we have a linear function, we get an arithmetic series. So let's look at some examples. Example number 3, evaluate each sum. So from 1 to 20 of 3k plus 2, 3x plus 2 is linear, and so the series is arithmetic. So we're going to get our first term by plugging k equals 1, right? So 3 times 1 plus 2, which gives 5. So that's our a value, right? A is the first term. If we plug in k equals 20 into here, we get our last term, 62. And we notice that the amount of terms n is 20, right? We're going 1, 2, 3, 4, 5, all the way up to 20. So n is 20. And so we're looking at our sum series formula. We have n, we have a, and we have l. So we plug that in, and so that sum right here is 670. Okay, let's do another example. K from 1 to 15 of negative 2k plus 1. Negative 2x plus 1 is linear, therefore the series is arithmetic. The first term is when k equals 1. Plug that in, we get negative 1. So that's our a value, first term. The last term is when k equals 15. Plug that in, we get negative 29. So our last term is negative 29. And we notice our n is 15. Going from 1 to 15, n is 15. So we have n, we have a, we have l. We plug that in, and this sum gives negative 225. Okay, time for some practice. Evaluate each sum. So 1 to 18, and this is 1 to 32, like that. Go ahead and pause the video and answer that. Okay, we're back. So a, plug in k equals 1 to get our first term, a equals 7. Plug in k equals 18 to get our last term, which gives 41. N is 18. We're going from 1 to 18. N is 18. So we have N, A, and L. Plug that in, and our sum is 432. B, we have 4x plus 1. That's linear. Therefore, it's an arithmetic series. So if we plug in k equals 1, A is 5. Plug in k equals 32. L is 129. N is 32, right? We're going from 1 to 32. So there's 32 terms there. So we have N, we have A, we have L, plug it in, and so it's 2,144 is the value of that sum. Okay, example number 4. We're going to write each sum in sigma notation. So here's our first sum here like that. We notice that A is 2, L is 47, and we notice that D is 3, plus 3, etc., etc. So we're going to use our sequence formula here. We know 47 is our last term. We know A is 2. We know D is 3. And so from here, we're going to isolate N to find how many terms do we have here. So we're going to go minus 2 to both sides, divide by 3 to both sides, plus 1 to both sides, and so N equals 16. So our sum is from 1 to 16, like that. We know it's a linear function, mx plus b. So that m is our d value. So it's 3x plus b like that. Or how we usually write it is 3k plus b when it comes to sigma notations. And so when k equals 1, this value, 3x plus b, equals the first term, 2. Therefore, b equals negative 1. So instead of 3k plus b, it's 3k negative 1 like that. So this is our sigma notation of this sum. And you can check it. I highly recommend doing a couple when you're on a test or something. Plug in k equals 1, you get 3 minus 1, which gives 2. Plug in k equals 2, you get 6 minus 1, which gives 5. And same thing, plug in 3, you get 8 like that. Okay, let's do another example, B. So A is 6, L is 82. We notice we're going plus 4, so our D is 4. From our sequence here, we're going to find out how many terms we have. So 82, A is 6, D is 4, like that. Minus 6 to both sides, divide by 4 to both sides, plus 1 to both sides, and so N is 20. So we know we're going to go from 1 to 20, like that. There's 20 terms. D is 4, so M is 4, so we got 4x plus b, but instead we'll write it as 4k plus b. When k equals 1, 4k plus b equals 6, right? So 4 times 1 plus b equals 6, and we isolate that, which gives b equals 2. So instead of 4k plus b, it's 4k plus 2, like that. And I'll leave it to check the next couple terms just to see if it's correct. Okay, practice number 4. A and B, write each sum in sigma notation. Go ahead and pause the video and do that. Okay, we're back. So using our Tn equals A plus n minus 1d, we know A is 7, we know L is 43, we know D is 3, plus 3, etc. like that. So we plug in what we know. We go minus 7 to both sides, divide by 3 to both sides, plus 1 to both sides, n equals 13. So we know the sum is going to go from 1 to 13 like that. D equals 3, so that's our m value here. So we have 3k plus b like that. When k equals 1, the 3k plus b is equal to the first term, 7, like that. So we get b equals 4. So we got 3k plus 4 as our sigma notation. B. A is 11, L is 106, D is 5, plus 5, etc. Plug in 106, A is 11, D is 5, like that. Minus 11, divide by 5, plus 1, we know n is 20. So we're going to go from 1 to 20 like that. Our m value is 5, so we got 5k plus b. When k equals 1, this 5k plus b is equal to 11. So B equals 6. So our updated here sigma notation is 5K plus 6 as such. Okay, example 5, evaluate each sum. So here we have a sum here from 1 to 8 of 2 times 3 to the k. Let's expand that. This is what it looks like. Compute that. We get 6, we get 18, 54, all the way to 13,122. We notice that it's a geometric series, times 3, etc., etc. This times 3 is what's underneath the k, like that, right? The base of the exponent, like that. And so this is where our r is. So our a is 6, r is 3, l is 13,122, like that. We have ARL in our sigma series, in our series equation, like that. And we get the sum of 19,680 as such. Okay, let's do another example here. Here's our sigma notation here. We're going to evaluate each sum. So when k is 1, we get negative 10. So that's our a value. When k is 12, we get 2480. And so that is our L value. R is the base of the exponent here, negative 2, like that. So we have A, we have R, and we have L. Plug that in, and our sum is 13,650. Okay, practice number 5. Evaluate each sum. So from 1 to 11 and from 1 to 8, like that. Go ahead and pause the video and answer that. Okay, we're back. So the first term is when k equals 1, which gives 28. The last term is when k equals 11, which gives 29,360,128, like that. We know our r value is 4. So we plug in A, plug in R, plug in L. And so that sum is 39,146,828, like that. Okay, B, we're going from 1 to 8 of 5 to the k. First term is when k equals 1, which gives 5. Last term is when k equals 8, which gives 390,625, like that. R is 5. We plug that in, and we get S8 being 488,280. And that's it. It's that easy. I'll see you guys in the next video.